All right, so here's what we're going to be doing. Rather than sitting there doing problem solving for like 4 straight days, okay, we're going to do this little group activity using maps and still doing some vector analysis at the same time while reviewing some V equals D over T stuff, okay, because that's going to be important going forward into projectile motion next week. So important to review that as well, okay? So in this activity, you are going to get a topographical map, sometimes called a topo, okay? It's actually going to be 3 parts that are going to go together, okay? A topographical map is kind of a dying tool, okay? I don't know why. They're awesome, okay? But everybody says, oh, I just Google map it. Well, you can't Google Earth a lot of places, okay? There's some places that the resolution is not good enough and you'll get hopelessly lost. So it'll be important for you to learn to use the map a little bit, okay? Now, on a topographical map, okay? And this is kind of, I'll blow it up a little bit. You can see, okay, that on a topographical map, there are these little lines. They're kind of all squiggly, but they follow the landforms, right? These little lines denote changes in altitude. The farther apart they are, the less steep that area is. The closer together they are, the more steep it is. So if they're right on top of each other, it's a cliff. Yeah, okay. Could be, this is still a mountain. Okay, but these lines are fairly far apart. But if I look, at a place like, in here where they're kind of right on top of each other, that's a cliff. Okay, so they help you to decide where you should go. Obviously going, oh, this is the quickest route. Yes, it is. But you'll die. Okay, yes, that's the quickest way from A to B, but you'd like to be, intact when you get to B. Falling off a cliff is not the fastest, it's the fastest way, but it's not the best way to get from A to B, okay? So you don't have a hang glider, you don't have a parachute, you don't have climbing gear, you have your feet, okay? And your arms. And no matter how fast you flap them, that isn't going to work, okay? So keep that in mind, because part of this assignment is planning a good route from one place to another. Sometimes that's easy because there's paths on the map, okay? So for example, if you see the big red line, that's actually a road, okay? That's the Moline Lake Road that goes into Jasper, okay? And then there's, you'll see sometimes dotted lines. Dotted lines can be trails, okay? Most of the time that's what they will be. So you can walk on those whenever they're available, all right? But we're planning our routes here along we're planning our routes along the map as follows. We're going to start at this point. You'll have your 3 maps glued together, or taped together, okay? And you'll go from start to cabin 1, and then you'll go from cabin 1 to cabin 2, okay? Cabin 2 to 3, 3 to 4, and then 4 to 5. You will end up here, okay, at the end of the whole trip. Sometimes there'll be a path all the way from one point to the next, and a lot of times there won't be, so you'll have to go off trail, commonly referred to as bushwhacking, okay? Because you have to work your way through the bush, which tends to be a bit slower, right? Everyone with me so far? Okay, so part of this thing is going to be talking about which way to go. Which way are you actually going to walk? Okay, so if I'm looking at day 1, okay, there's actually a trail that goes from start to cabin 1. You can't really see it on here, but that would be like the most logical way for me to go would be, yeah, follow the path. They usually make a path because, well, that's the smartest way to go. Now, how am I going to measure how far I went? Well, I could sort of, except that I don't really know what the grids are, and that's a crooked line. It's a little secret for you. If you're following a crooked path, put something that can take its shape on top of it, like a headphone cord or a charging cable. Okay, just take that and make it take the shape of your path, pinch the 2 ends at start and finish, straighten it, and measure. Yeah, shoelace will work too, okay? But usually people have a headphone cord or a charging cable. That works great, okay? Because a charging cable is a little less, it kind of takes the shape and kind of stays there, okay? So that's how you would measure the distance traveled from one place to the next. Now, distance is scalar or vector? It's scalar. All right, so this will just tell you how many meters it is. All right, now the scale on this map, okay, is 1 to 50,000. Okay, that means on the map, 1 centimeter equals 500 meters in reality. So when you measure that distance with your headphone cable, and then you stretch it out and you get that it's 10 centimeters or whatever, you got to multiply that by 500 to get it in meters. Everyone with me on that? Okay. All right, so that's one of the things that you will have to do for each of the days, okay, is calculate the total distance that you have traveled. Okay, it's a pretty easy measure. The next thing you will have to calculate or measure, okay, is your total displacement. All right, now your total displacement is the straight line from where you started to where you finished. All right, so on here, okay, that would look something like this. Okay, that line represents my total displacement. Now, I can get its magnitude very simply by throwing a ruler on there and measuring it. But I also need its direction. Luckily, as David pointed out earlier, maps have grid lines on them. They will allow you to get the vertical and horizontal components of this displacement by simply doing what we've been doing. Okay, I draw a line that's parallel to the north-south lines, and I draw a line that's parallel to the east-west lines, and I now have the y and x components of that vector. Would I then be able to calculate its vector? Yeah, a little bit of trig, okay, nothing you haven't done before, and then I would have it. That's one of the other things you have to do for each day. So I'm going to want distance for each day and displacement for each day. Right? Now, here's where it gets crazy. I'm also going to want speed and velocity for each day. To get those, I need to know what? Time. Okay, so that's where all these special rules for being out in the wilderness come into play. Okay, here are the rules. Rule number 1, altitude affects speed. Okay, if you've ever gone scrambling, mountain climbing, hiking in the mountains, you know that altitude affects speed because the higher up you go, the thinner the air gets, the more you suffer. Okay, the harder it gets to do anything. If you ever watch people who climb Mount Everest, okay, they're A, crazy, okay, and B, they get really tired at the top, no matter how good a shape they're in and no matter how much supplemental oxygen they carry. Okay, every step is like running 100 meters full out. Okay, that's why you see them do this. And then they sit there and they breathe and they breathe and then they take another step, okay, and they breathe. It's just agonizing because there's so little oxygen, and that's wearing supplemental oxygen. Okay, they suffer that much at that altitude. We're not going to be going that high because there aren't any mountains that high in the Rockies. Okay, but altitude still affects speed. So here's what you need to know: if you are on the trail, so if you're on a dotted line somewhere, okay, and you're below the tree line, okay. The tree line is any areas that are green, okay? That would be in the trees and on a trail. Then you can walk at 1.5 meters per second, which I know that seems slow, but actually it's a pretty good clip if you're carrying a pack, okay? If you are above the tree line and on a trail, you can walk at 1.2 meters per second. You slow down a little bit because the air is thinner, okay? So on the trail, you can walk, fairly quickly. Rule number 2, the Bushwacker Rule. You're going to have to go off trail in this, okay? I've made it that way on purpose so that you can't always walk on the trail, okay? If you are off the trail and you've decided I'm going to walk along the river or I'm going to walk through these trees or whatever, and you're not on a trail, okay? Then below the tree line, you can walk at 0.75 meters per second. Above the tree line, where there are no trees, you can walk at 1. You can actually walk faster at a higher altitude off trail. Why? There's no trees, okay? If you're in the trees, it's not altitude that kills you. It's the fact that there's bushes and things to trip you, and it's really hard. You don't want to do it, okay? So those are the rules for being on and off the trail and different altitudes. Everyone following so far? These numbers are going to help you to calculate how long it takes you to walk from one place to the next, right? So if I'm looking at day 1 here, day 1 is all on trail below the tree line. So all of day 1, I would walk at 1.5 meters per second, okay? If I was over here, okay, and I was following a trail like this, okay, I would have a couple of different sections. I would have to divide it up, okay? This part here would be off the trail and below the tree line. This part here would be off the trail above the tree line. So I'd have to measure them individually so I'd know how far I walked, and then I could use the speed during that section to calculate the time. It's just V equals D over T. Okay, it's nothing hard. You just have to plug in the right V for each section. And then here again, I'm back below the tree line, okay, off the trail. I can calculate how long that part takes me, okay? All right. The third rule is the silly salmon rule, okay? In the mountains, water levels can vary, and they can vary very quickly. That's two different kinds of vary, by the way. That's the ERY and the ARY, okay? They can change very, very fast. So crossing a river is not something you do without care or you die, okay? So lots of times, you don't want to get your socks wet for the rest of the day, or you don't want your boots all wet or whatever. So you stop, you check for a good spot to cross. I mean, if you're on the trail, well, you have to stop and wait because there'll be a what? Right. If you're off trail and you're crossing a river, then you got to take your time and you got to find a good spot to cross. That takes time. Okay. You got to take your boots off, walk in your bare feet or your sandals or whatever. Okay. But it's going to take you an extra 15 minutes. Every time you cross a river where there's no bridge, add 15 minutes to your total time. Okay. That's the silly salmon rule. Okay. So what I'm going to want to see here is as follows. I'm going to want to see your map. Okay, so as a group, plan your routes. So draw them on there. How am I going to get from 1 to 2? How am I going to get from 2 to 3? What way am I going to walk? It's got to be reasonable. Okay, I'm going to want to see your vectors with their components drawn on the map as well. You don't have to show me calculations on the map. You're going to show those on a separate sheet. I just want to see, the path and the vectors drawn on the map. Everybody with me there? For each day. And for the total, right? So your vector for the total. Obviously, you don't draw a line along the road. You didn't walk there, okay? Just the vector, the total displacement at the end, okay? Everybody follow me on that? Okay, so that's going to want to see on the map. Then the calculations I'm going to want to see, okay, are as follows, okay? So calculations of distance, speed, displacement, velocity, and time for each day, okay? Each day has a distance, a displacement, a speed, a velocity, a time. Okay, 5 things for each day, right? This is where people screw up, okay? They forget some of those things, and then they lose marks as a result, okay? Those 5 things: distance, displacement, velocity, speed, time, okay? I mean, you have to have the time to calculate speed and velocity anyway, right? Okay, for your vectors, which of these 2 things should have a vector on them? Displacement and velocity. You'd be surprised how often people forget to put it on the velocity. They always remember to put it on the displacement, but then they write down a velocity with no vector. And it's ridiculous because the vector is the same. Yeah, it's the same number. They just don't put it on there, and then they lose marks because they showed me that velocity was a scalar quantity. All right, so make sure you got the vector on your displacement and your velocity. They're the same number. It's not extra work, just a little extra writing. Okay. All right. So calculations of those things: triangles drawn on the map and the paths you followed. Calculations of total distance, total displacement, total time on trail, and average velocity for the entire trip. Okay. So for each day and the entire trip. Basically, that's just adding everything together, right? So it's not hard. All right. And then your group will hand in your map along with your calculations, okay? You can color code the sections. A lot of people do that. So like for this day here, it was all on the trail, so it was all red. But, for this day here, instead of drawing it the way I did, okay, maybe instead they use, red for one part, and then they go, okay, when I'm using a blue line, that's when I'm only walking at 1.2 meters per second or 1.0 meters per second or whatever, okay? You can color code it so it's easy to keep track of and easy to do the calculations. Okay, so that's what I'm looking for from each group. Now I have the maps over there. I'll bring them up front here. Just send a person from each group up to get a map for the group. Now, a caution here. It is possible the map can get lost. So what should you do at the end of each day? Take a picture of the map. Take a picture of the calculations, just in case whoever's in charge of them loses them. It happens. It's not because they're irresponsible most of the time, okay? It's just stuff happens, all right? If we take a picture of it every day, nobody loses. It's just a matter of recopying then, okay? Not a matter of reworking everything, all right? So let's say, you can pick your own groups here. If anyone's without a group, just let me know and I'll make sure you get one. Let's say groups of like 3 or 4. okay? But no bigger than that, or there isn't enough work to go around. Now, you got to break this work up. I don't want to see one person slaving and 5 people chatting, okay? Everyone should be given some role to play in this activity. You can break it up by day. You're in charge of day 1, you're in charge of day 2, or you can say you do all the displacements, you do all the velocities, you calculate the times. I don't care how you break it up, but make sure everybody's got a job, okay? Now, here's group skills. Sometimes there's conflict, okay? We're not going to solve that by kicking, scratching, or biting, especially biting, okay? That's really gross, right? If there's a problem, okay, then try and solve it. Try and make it work amicably. If you can't, then you come to me. I'm really good at solving problems because I'm mean, okay? So if there's a problem, come to me, all right? Questions on what we're doing? All right, so I will bring the maps up here, send one member from each group once you decide who they are.